So basically, up at the top of your page is kind of the wrap-up of what we're going to be up to today. When we distribute, we can do that to simplify our polynomial. Now, a lot of times we just do it with arrows, and we're going to do that too on some of these, but I'm also going to show some of you a technique I like to call the box, which if some of you are a little bit less, kind of, we'll just say, nicely disorganized, it might help you to make this a little bit easier. But just like it says on the reminder down here towards the bottom of this, adding exponents, multiplying coefficients, the number in front, and then we'll combine like terms if there are any. And sometimes there will be, and sometimes there won't. So up here at the top, when it says find each product, I'll show you a couple of things here. Thank you. That may end up working out okay for us. So let me kind of introduce the box, then you can tell me if you think this is any good or not. What I do is I take my one term, I put it on the outside here, and then I put each of my terms in the parentheses along the other side of my box. And there's only two boxes there because there's only two terms. What this does is it helps remind me, oh yeah, I'm multiplying on these. So it helps me remember, okay, I got an exponent of 1. And if I want to on these, I can even put a 1 in front of my number just so when I go to multiply, I've got something to multiply by. So like here.
Why are you making that 1 have a...
Like here?
No.
This?
Yeah.
Because anytime I've got an x, the exponent's always 1. And the reason I'm putting it there is when I go to multiply right now. Yeah, anytime there's an x, there's always going to be some sort of an exponent. Because if I don't have one, sometimes people forget about it. Because when I go to multiply these, I add their exponent. So if I see it, I know it's 1 plus 1. Which means this is x to the second, or x squared. Right. The number in front, we still just multiply. So here, 1 times 1 is 1. But then when I get to the x's, add the exponents. 1 plus 2 is 3. Now, here's the question. Can I combine these and call it like 6x to the 5th? No. Okay. Different exponents, there's no like terms to combine. That problem's done. Now, some of you are saying, can I just keep doing the, the arrow thing like we did before? Do I have to draw this box? No. Okay. Now this will come in handy when we get into some bigger ones in a minute, but I just wanted to introduce you to it before we got there. So I'll do it on one more, and then I'll let you guys kind of tell me what you think of which way we should go about doing it. But I am going to keep doing this. I am going to keep putting my exponents on here. I'm not going to quit doing that. So let's see here. First box. I got a 4. Okay, so 4. What's my exponent on my x's going to be in the first box? 3, because I'm adding my exponents. 1 and 2 gets me to 3. So in the next box here, I've got a plus 3. Add up my exponents. What's my exponent going to be this time? 2, because I got 1, and 1 more is 2. I'm just adding up my exponents. Now this last one, there's not a whole lot to think about. I've got the 2, and this is my only x term. So it's just x or x to the first. And the nice thing about the box is it kind of organizes all my terms too. I'm like, okay, I got any other x to the thirds? No. Have any other x squareds? No. Have any other x? No. Okay, and I'm done. Now again, box is cool. If some of you are like, I like just doing the arrow thing instead, okay, we can try that too, because they both work. So if I do that here, okay, what's negative 2 times positive 2? Negative 4 I've only got this term right here that's got an x, okay, because I'm only working with these right now, so I've got x to the first. And then y, well, y to the 1 plus 2, because I have 2 of them, so y to the second. And then I do that again out to this one. So negative 2 times 4 is negative 8. What's my exponent going to be on x this time? 3, because I got 1, and 2 more is 3. And I've only got the y the way it is. Now, even though both of these have x and y, the exponents aren't the same for both. Why is this y here? Because I'm multiplying this times this. So I do have a y in this part, even though there's not in the actual term. What I'm doing right here is I'm doing negative 2xy, make sure I squeeze this in here, times 4x squared. I'm multiplying those together. So I still do have 1y here. That's where that's coming from. Okay.
Well, I thought the negative 4xy. I was getting that y from there.
Okay. No, because what I do, let me draw it back this way for a second. Maybe this will clean it up a little bit better for us. Thank you. So I'm multiplying this negative 2xy times each part once. It's not like I'm only just doing it one time. And so when I do it to each part, x, and I got 1 and 1 is 2, so that's where this came from. And then I just do it one more time over here, but now with the x,
The y is going over there.
and then the y is going over here too. Yep. So again, whether you just do it with the arrows or you do it with the box, for some of you I think the box might actually end up working better to kind of keep this simple. So like if we get to, let's go to 6. Let's go right below here. Okay. Let's see if our organization helps us out here. So the negative 4x goes here. And I put these along the top. I don't know whose it is, but somebody's music's a little too loud when I can hear it. It's getting closer. I need to invest. Oh, I can't say that. I'm actually recording right now. I could say it, but I won't.
Scare the audience.
No, I'm not going to scare the audience. I was going to say I need to invest in hearing aid companies because I met a lot of deaf people when they get to be my age even. All right, so when I get to here, again, multiply the numbers in front and add your exponents. And you're like variables, because when we multiply, we're adding the exponents. What's my second box going to look like? Okay, positive 8, because negative times negative is positive. X to the second, because I add my exponents up. And this last one, I just got the numbers to work with. And again, if I don't see anything that's alike as far as my exponent terms go, I actually could just leave it in the box and circle it. So the only time I'd have to really worry about it is if I had. So actually, let's stay on a roll with this. We're kind of going down here. Let's do 9. 9 looks like a big bunch of craziness. And again, if you see a variable and it doesn't have an exponent, I would stick a 1 on there just to remind me that it is there. And again, as you start to fill in the box, multiply the numbers in front, add your exponents on your like variables. So 2 and 1 is 3. 2 and 1 is 3. multiply your coefficients. So 2 times 2 is 4. I don't see any other x's here, so I'm just going to use the ones I have. Then I'm going to add the exponents on my y's. Last box. 2 times 5 is 10. Add my exponents on my x's. So 2 and 1 is 3. And I don't have any other y's. Let me take a close look here to make sure none of these are the same. 3 and 3, 2 and 3, 3 and 2. Nope, those are all different. So I'm basically just done and ready to go. Okay. So whenever I'm distributing, that's my main purpose. That's what I'm up to. Now, it can, though, become sometimes that when I'm done distributing, there might be something that's alike. I can have like terms. So, let me bump this up just a little bit here. Yep, this is notes. I'm sorry, I did not label that right away. Yes, this absolutely positively is notes. Let me come back down here for a second. Make sure we get that in here. Glad you made me aware of that. So when I get to 10, again, I can box things here if I want to. Or I can say, you know what? I got this. So we'll try one with and one without, kind of see what we think. So when I get here, I've got my 3. Add my exponents, so 1 and 1 gives me x to the second. Working on out here, got a negative 4 x to the first. And then this minus 5x, I don't distribute to it. It's not in the parentheses at all. So I'll just rewrite that one. So it's not in the parentheses. Don't send that x out there to multiply. Do I have any like terms this time? Yes. These two, because they're both x to the first. So just rewrite my 3x squared. So think money. If I owe somebody $4 and I borrow 5 more, I owe them 9. No messing with exponents, just combining like terms. And again, for a lot of you, this is just going to be the idea of just doing some organization. So again, I'm just going to keep giving you options. And just find the one you like and roll with it. So like for number 11, for instance. Okay, some of you may want to keep going with this box concept because it just organizes you. And that's fine. Okay, I'm not putting the negative 6x squared with my box. I'll do that later. So just like before, this is like a negative 1. So negative 1 times 2 would be negative 2. And add my exponents. 1 and 2 is 3. Multiply my coefficients. Negative times negative is a positive 4. 1 plus 1 would be x squared. So once I did that box part, here's what I'd do then. I'd say, okay, so I've got negative 2x to the third plus 4x squared. But now this minus 6x squared that I haven't done anything with yet, I'll go ahead and I'll write that down. And now I take one last look and I say, okay, what do I have that's alike? Well, these two, they're both x squareds. So I'm like, okay. So if they're both x squareds, again, I gotta watch for signs though. I have $4, oops, I went and spent 6. I'm $2 in the hole. And that's how I can get to my last answer. Now, sometimes with these, if we get to one like 12, if you're a box fan, you may have to do 2 boxes. That's okay. So here I've got 6a and 2a minus b. And I have 2a negative 4a plus 5b. Again, it's about organization and getting to the right answer. If you feel comfortable just going, that's fine. But otherwise, add my exponents here. And just keep to the same cause. 6 times 2 is 12. Add my exponents. 6 times negative 1 is negative 6. A to the first, b to the first. Ooh, there's a first time we're starting to get into multivariables in one part here. And then we'll do the same thing in the other one. 2 times negative 4 is negative 8. Add my exponents on my a's. 2 times 5 is 10. And I have one of each. And you're like, okay, so now what? Well, if I look, I can even look where they're at right here and find things that are alike. So like I notice this 12a squared and this negative 8a squared, both have a squared, so I can put those together. So 12 minus 8 is 4a squared. And then I look at my other terms, I'm like, oh, these both have a to the first, b to the first, so they're the same. And if you want to use colors, I've always got the colored pencils up front to kind of help you combine like terms. If I got 10 of them, but then I use 6, I got 4 left. Not messing with the exponents though. Still keeping those exactly the same. So when it comes to simplifying, doing this polynomial by a monomial, that's all I'm doing. I'm just kind of multiplying.
When you have the two, like the exponents,
Uh-huh.
so you don't use the same note.
Right, once I've filled in the boxes or distributed, I'm not messing with the exponents anymore. Yep, we're just combining like terms. Like for instance here, right, I'm not doing like 2 and 2 and making that 4. Nope, wouldn't want to do that. Okay, so let's flip over here. So when we get to the back, because some of you have mentioned some concerns before with doing some solving on some things. So here I can do those same types of things. So if we take a look, just a couple of these. I say, all right, let's see what we got working here. So if we look at 20, I multiply the 3 times each part that's there. So 3x, 3 times 5 is 15. I don't distribute to the negative 6. It's not in the parentheses. And now I'm going to deal with this just like I was dealing with the stuff before. Do I have like terms on the same side of the equals? Okay, and that's the key. Are they on the same side of the equals? If they are, I can just combine like terms. If I got 15 and I take 6 away, I'm left with 9. If I want to solve for x, what do I need to do next? Yeah, minus the 9. And then divide. So this is actually going to help us become better equation solvers too, the whole distributing and combining like terms that goes on. If I'm doing that with 24, first I'm going to distribute the 3 through to my first set of parentheses. Okay, and make sure it's to both, not just to the y at the start, that it's to the y end of the 5. And my second one, that minus, is like having a negative 1 that I'm multiplying through to both parts. And basically all the negative 1's going to do is change signs. Negative 1 times 4 is negative 4y. What happens when I do negative times negative?
Positive.
That becomes positive. And so once I get to here, now I just say, okay, 3y. Ooh, if I got $3 and I go and spend 4, I'm 1 in the hole. But if I have $15 and I find another 8 in my pocket, I now have 23. And now, just like up above, my goal is to get the y by itself. So what would I need to do next? Right, subtract the 23. And then I'm not quite done until I divide by the negative 1. What's that? Oh. So again, just take your time, distribute through, and then just put the like terms together. So it's like, okay, Hardy, you got to be running out of things to come up with using this stuff. I got one more trick up my sleeve. One last trick. Flip over one more time. Okay, and again, this whole packet we're playing with here.
It says first inside, outside, left. That doesn't spell forward.
Well, if I change these two around, first outside, inside, last, then it will. So yeah, I needed to flip those around because otherwise now I have FIOL. I don't want FIOL. FOIL is much better to use. And FOIL just means I basically am just using arrows to do everything. Now to me, that's confusing. If I sit and look at two of these and I'm going, okay, my first one's in my outer and my inner and my last, all I'm seeing is a bunch of lines and I'm trying to remember what did I do, what did I not do, I don't know. So here's where that box I talked about before, here's where it really does work well. Because now when you line up the terms along the outside, everything gets organized for you. Not only that, your like terms will even get organized because they'll always be in the same diagonal from each other. So here's where I'm going to skip down to. Because we just got done doing a bunch of stuff in like 1 through 8. So I'm going to come down to 9. And we're going to take a peek at how this box thing would work with one of these.
Is there a simple way to make them on a box at a problem?
You can do the FOIL and kind of use the lines if you want to.
That's not simple at all.
Yeah, I don't find that to be simple. That's why I find this to be a much better option. So if I don't see exponents, I'm going to put my 1s in there. And basically, the box is going to do all the work for me.
I don't want to have to draw the logic.
Well, you can try mental math, or you can try the lines. There's not a whole lot of other options. Sometimes we just got to find ways with stuff to do what we got to get to the right answer. And then I just kind of move my way along. So like this next box is going to be 8 times 5x. Well, 8 times 5 is 40x. Negative 6 times x is negative 6x. And negative 6 times positive 8 is negative 48. And like I said before, the nice thing about this method is your like terms will always be together in the diagonal. So when I go to write my answer, I write the 5x squared. Then I'm going to put these together. So if I have 40 and I take away 6, I still have 34. And then the minus 48 at the end. And I even get it into standard form that way. Very nice. So as I'm doing these, okay, if I go ahead and even do the one right below it, the format's not going to change on me. And the nice thing about this is it works for any size. If there's one term to multiply by, if there's 2, if there's 3, doesn't matter because this always works. b's, I add up my exponents because I'm multiplying. We multiply to fill in the box, and then we combine like terms. So I've got a negative 5, b to the first. I've got a positive 5, b to the first. And 5 times negative 5 is negative 25. And again, my diagonals are my like terms. But this one's kind of different. Because I got b squared. Wait a minute, 5 and minus 5, they cancel each other. That's right. So those will go away. And I'll just have the minus 25. So I can end up with just two terms. It's definitely possible. But to see the box in its glory, to see it in its absolutely most awesome format, I've got to show you this, because this is where the box is so much better than drawing lines. To the back. Oh yeah. Behold, number 20. You're like, what the? Now this, the box can go to any size that you want it to. I'm starting to sound like an infomercial from TV, like I'm trying to sell you something. So I've got two terms down the side, and I have my three terms along the top. Get my exponent in here. And I start filling in my box just by multiplying the terms together on the outer edge. 3 times 3 is 9. 1 plus 2 is 3. 3 times negative 2 is negative 6. Add my exponents. 1 times 3 is 3. There's no other x's there, so I'll just leave that alone. And then I start with my next group here. So 3 times 2 is a positive 6, x squared. 2 times negative 2 is negative 4, x to the first. And 2 times 1 is 2. This is where we get to see the awesomeness. If you start in the upper left corner, each, yep, as you start working through the diagonals, the squares are the same, but you're right, 6 and negative 6 cancel. So then I work to the next group. 3, ooh, but I spent 4, so I'm behind 1. Notice, not messing with the exponents anymore. Multiply to fill the box, and then we're just combining like terms. Is it a little bit of a process? Yes. Yes, it is. But again, if you organize it like this, as long as you do your multiply rules fine, you end up in really, really good shape. Okay. One last one and I'm done. I swear I'm done after this one. Okay, 17. What happens if they give us a squared term? Well, it doesn't mean I just distribute the squared and call this y squared plus 49. It doesn't quite work that way. The squared means I have two of these y plus 7s, or whatever happens to be in the parentheses. So once I have that, again, if you're more of a fan of just drawing the lines with... No, because this squared means I just have two of them. So if I write two of them out separately, I'm taking care of that already. So once I get that written and get my handy exponent in here, I just do my thing. Y and y is y squared. 7 times y is 7y to the first. 7 times y is also 7y to the first. And 7 times 7 is 49. And again, if you always start in the upper left-hand corner, 7 plus another 7 is 14. Still y to the first, though. And then the 49's at the end. Organizes everything in just a beautiful order for me. It's great. Okay. So we've got an example of everything now. Everything that you could possibly run into. So your task is to now take this sheet to help you work through the practice. Now there's some on there you're just going to distribute, some where you might want to use the box, okay? Up here you could use a 1x2 box. We did that in some of the examples. But once you start getting down to like number 8, number 9, number 10, okay, using that box is a good organizational tool. And as you head towards the back, there's more of those and a couple of the bigger ones, like the one we just did. But again, it's a process that you've got to get used to, because there's a lot of things as you move on in math that have to do with multiplying things out, FOILing, and then later on factoring. So work on this tonight. Tomorrow, I don't think there's going to be anything new. I think we're going to kind of blend this stuff together and make sure everything's going okay. And that's kind of our game plan.